Could Ibrahim Traoré really replace part of Burkina Faso's imported steel with bamboo? It sounds almost impossible. Steel builds bridges, buildings, factories, and entire cities. Bamboo grows from the ground. But Burkina Faso imported roughly $351 million in iron, steel, and related products in 2024. And if even a small part of that dependence could someday be replaced by a material grown and processed locally, the consequences could reach far beyond construction. Before the first third, we will show what bamboo can realistically replace and what it cannot. Midway, we will uncover the industrial system needed to make it work. And at the end, we will reveal the two numbers that decide whether bamboo could become a real tool of self-reliance. Because growing bamboo is easy. Building an industry around it is not. If that opening question sounds radical, it should. Because the first thing we need to establish is what is real and what is still only possible. Burkina Faso did import roughly $351 million in iron, steel, and related products in 2024. But that number does not mean the country spent $351 million on construction steel alone, and it certainly does not mean bamboo could replace all of it. That is the first trap. The useful question is not, can bamboo replace steel? The useful question is, where could bamboo replace imported materials without creating a bigger technical problem? And once you ask the question that way, the story changes. Burkina Faso has been pushing a broader vision of self-reliance, produce more locally, keep more value inside the country, and reduce exposure to outside supply chains. The government has also promoted large-scale reforestation. In 2025, a national campaign targeted 20 million planted trees. There is another reason this matters. Burkina Faso's own architectural community already recognizes bamboo among natural and traditional materials used in the country. So this is not a fantasy material imported into the conversation from somewhere else. The raw resource has cultural and practical relevance. The unanswered question is whether that familiarity can be converted into repeatable industrial performance. But here is the first major crack in the story. We have not found public evidence that Ibrahim Traoré has launched a national program to replace structural steel with bamboo. There is no verified national bamboo replacement target, no publicly confirmed promise to substitute a fixed share of steel imports, and no evidence yet of a large national bamboo processing system operating at scale. So why does this idea matter at all? Because bamboo is not just a plant. In the right applications, after treatment, grading, engineering, and testing, it can become a construction material, a panel, a structural component, furniture, fencing, housing material, or an input into a wider manufacturing chain. And that creates a much more important possibility. What if the real opportunity is not replacing steel directly, but replacing a slice of the value that currently leaves the country? Think about what happens when Burkina Faso imports a finished component. The country is not only paying for raw material, it is also paying for processing machinery, engineering certification, logistics, and someone else's industrial margin. Now, reverse that chain. A nursery supplies planting material. A farmer grows bamboo. A processor treats and dries it, a workshop turns it into usable components, engineers test it, builders learn how to work with it, buyers create demand. If enough of those steps happen locally, the country keeps more of the value. That sounds promising. But this is where the second hook appears. A bamboo stalk growing in a field is almost irrelevant to industrial policy unless someone can turn it into a product that engineers trust. Fresh bamboo contains moisture. It can split. Untreated material can decay or suffer insect damage. Dimensions vary, strength varies, connections can fail, building codes matter, testing matters, insurance matters, and once all of that enters the picture, the cheap local material may no longer be cheap. So now the question becomes harder. Would Burkina Faso actually be replacing imports or simply replacing imported steel with imported treatment chemicals, imported machinery, imported connectors, foreign certification expertise, and outside technical know-how? That distinction is where self-reliance either becomes real or collapses into a new dependency. And if you want African development measured by working systems instead of slogans, tell us the city or country you are watching from and subscribe as we test these claims against what can actually be verified. Because before we ask how much steel bamboo could replace, we first need to follow the invisible chain between a field and a building site. Cut a bamboo stalk today, and you still do not have a building material. You have a biological raw material with a countdown already running. From the moment it is harvested, moisture begins to matter. Drying matters, insects matter, cracking matters, storage matters, and if any of those steps are handled badly, the material that looked cheap in the field can become unreliable before it ever reaches a construction site. That is the hidden system behind the phrase green steel. It begins long before construction. First comes species. Not every bamboo behaves the same way. Different species grow differently, mature differently, and perform differently. Then comes land, water, and nursery capacity. A country can announce planting ambitions, but industrial supply depends on whether the right material is available in the right place in the right volume year after year. Then comes harvest. Harvest too early and the material may not have reached the performance required for demanding uses. Harvest too late or inconsistently, and processors face another problem variation. Industry does not like surprises. A factory needs repeatable inputs. Then treatment. Untreated bamboo can be vulnerable to biological attack and deterioration. That means a serious construction chain needs processes designed to improve durability before the material reaches a builder. Then drying. Too much moisture creates another layer of risk. Drying has to be controlled because the material must become stable enough for processing, storage, joining, and use. Then grading. This is where the story starts to sound less like farming and more like manufacturing. A construction company cannot simply buy bamboo. It needs to know what kind of bamboo, what dimensions, what moisture condition, what strength class, what treatment history, and what application the material is suitable for. Then comes processing. Some applications may use poles, others require strips, laminated sections, panels, boards, or engineered components. Each additional step can create more value, but each step also requires equipment, energy, trained workers, quality control, and money. And then we reach one of the most important technical problems, connections. Bamboo can perform strongly along its fibers, but a structure does not fail only in the middle of a perfect member. It can fail where pieces meet. Joints, fasteners, crushing, splitting, and connection design can determine whether an apparently strong material actually performs safely in a real structure. That is why a headline about strength is not enough. A building is not a laboratory sample. It is thousands of loads moving through thousands of details. And even if treatment and connections are solved, another gate still remains testing and standards. Engineers need repeatable data. Builders need rules. Inspectors need criteria. Designers need to know what loads a component can safely carry. Public agencies need standards they can enforce. Insurers and lenders need confidence that the material will behave as expected. This is the difference between a local resource and an industrial material. And every missing institution testing lab, grading rule-trained inspector, reliable processor becomes another place where dependence can quietly return. A bamboo stalk grows biologically. A building material grows institutionally. And now we can finally answer the first promise from the beginning of this video. Can bamboo replace steel? In some applications, bamboo or engineered bamboo may compete with materials that would otherwise be made from timber, metal, or other conventional products. It can be useful in panels, interiors, furniture, lightweight structures, housing components, certain structural systems, and other carefully designed applications. But bamboo is not a universal substitute for steel. It does not mean that conventional reinforcement high-load structural steel bridge members, industrial machinery fasteners, or every metal component can simply disappear. The mistake is comparing one attractive strength number from bamboo with one strength number from steel and then pretending the two materials are interchangeable. They are not. The real opportunity is more selective. If Burkina Faso could identify applications where bamboo is technically suitable, process it locally, certify it, and deliver it at a competitive cost, then every successful substitution would represent something more meaningful than a material experiment. It would represent a piece of industrial capability that did not exist before. But that creates the next problem. Producing enough bamboo is only the first test. Who gets access to this new value chain is the second. Imagine two farmers standing only a few kilometers apart. Both hear the same promise: bamboo could become part of a new local construction industry. Both have land. Both are willing to grow. But from the first day, they are not entering the same system. The first farmer belongs to a cooperative. He has access to a nursery that can supply the right planting material. He knows which species the processor wants. He has enough water to establish the crop, technical advice on spacing and harvest age, and a truck that can move material when the buyer calls. Most importantly, he knows there is a buyer. Before he plants, he already understands the specifications. That changes everything. Now consider the second farmer. He has a few hectares and the same enthusiasm, but no irrigation. No cooperative, no clear standard, and no guaranteed market. He may grow bamboo successfully for years and still discover that the processor does not want his culms because they are the wrong size, the wrong age, too wet, poorly treated, or too expensive to collect in small volumes. The crop can grow. The market can still fail him. These are not two verified individuals. They are analytical cases designed to expose a problem that appears in almost every new value chain access. Who gets the planting material first? Who learns the standard before everyone else? Who gets financing? Who owns the truck? Who can deliver the minimum volume? Who can survive a rejected shipment? And who gets paid quickly enough to plant again? Those questions may sound administrative, but they determine who captures the first wave of value. If a bamboo industry begins to grow, the farmer is only one participant. There is also the nursery operator, the treatment center, the transporter, the processor, the construction company, the machine supplier, the importer of chemicals, the testing laboratory, the engineer, the distributor, the landowner, and possibly the public agency deciding which projects are allowed to use bamboo in the first place. Every one of those actors can become a gate. And if public construction becomes the first major buyer, procurement rules can become another gate deciding which firms qualify, which standards count, and whose products are accepted. That does not mean the system is corrupt. It means every industrial system has access points, and whoever controls those access points can influence who enters, who waits, and who absorbs the risk. This is why local production alone does not guarantee local prosperity. Suppose farmers grow bamboo in Burkina Faso, but the treatment chemicals are imported, the presses are imported, the replacement parts are imported, the certification expertise comes from abroad, and the highest value engineered products are manufactured somewhere else. The country may still create jobs. It may still keep more value than before. But the structure of dependence has not disappeared. It has moved. And this is where the money behind the idea begins to matter, because whoever finances treatment plants, processing equipment, testing facilities, and large procurement contracts may also influence who controls the gate. A local farmer can own the stock and still have almost no power over the final product. Now move downstream. Imagine a family trying to build a home. They do not care whether a material is described as green, local, revolutionary, or sovereign. They care about price. They care about safety. They care about maintenance. They care about whether termites will damage it, whether a contractor knows how to repair it, and whether replacement parts or treatments are available 5 years later. If bamboo enters the market before the supply chain is mature, that family could end up paying the cost of an immature industry. The material might be local, but the final house might not be cheaper. That is the uncomfortable part of import substitution. Replacing an imported product is not automatically progress if the domestic alternative is unreliable, inaccessible, or controlled by a narrow part of the chain. The stronger version of self-reliance is not simply, we made it here. It is, we built a system that ordinary producers can enter, workers can learn from, buyers can trust, and consumers can afford. And that brings us to the question hiding underneath the bamboo story. If Burkina Faso ever builds this industry at scale, who will own the most valuable parts of it? Will value remain with growers, local processors, engineers, and manufacturers? Or will the country grow the raw material while the technology, financing standards, and margins remain somewhere else? That is not a question bamboo can answer. It is a question about power. After following the public evidence as far as it will take us, the most important fact may be what we cannot find. There is currently no publicly verified national bamboo-to-construction industrial system under Ibrahim Traoré. We have not found a confirmed national production target for construction-grade bamboo. We have not verified a major processing network operating at industrial scale. We do not have a published substitution target showing how much imported steel or other construction material the country intends to replace. And we do not have verified national figures for factory output financing structure ownership or certified commercial throughput. That does not prove nothing is happening. It means we cannot responsibly describe a bamboo revolution as an operating national industry yet. And that distinction matters because the same raw material could lead to two very different futures. In the first future, the value chain is transparent. Growers know exactly which species and dimensions processors require. Treatment standards are public. Testing methods are published. Engineers and technicians are trained locally. Procurement rules are visible. Processors report how much material actually moves through their facilities. Public projects disclose cost performance failures and maintenance, and farmers can see where the value goes before they commit years of land and labor. In that system, outside capital or imported machinery would not automatically be a weakness. They could be tools used to build domestic capability as long as skills, maintenance, knowledge, engineering capacity jobs, and an increasing share of the value remain inside Burkina Faso. Now imagine the second future. Farmers sell raw bamboo cheaply, but the high-value processing is concentrated elsewhere. Specialized machines remain imported. Treatment inputs come from outside. Technical standards are difficult for small suppliers to understand. Procurement becomes opaque. The country celebrates a local material, while the highest margins still sit in processing certification technology and distribution controlled by a narrow part of the chain. To be clear, this is an analytical scenario, not an allegation about an existing bamboo industry in Burkina Faso. But it exposes the real test. The dividing line is not simply bamboo versus steel. It is not even foreign versus domestic. It is capability versus dependency and transparency versus capture. A country can import a machine today and become more independent tomorrow if that machine helps local technicians learn local firms produce and local suppliers move up the value chain. Or a country can grow its own raw material and remain dependent if every critical step after harvest belongs to someone else. That is why ownership matters. But ownership alone is still not enough. A locally owned plant that cannot maintain its equipment, meet safety standards, deliver consistent quality, or sell at a competitive price does not create sovereignty simply because the paperwork says domestic. That is the uncomfortable midpoint of this story. The most visible symbol would be the bamboo itself, but the decisive assets could be almost invisible. A treatment formula, a testing protocol, a spare parts network, a certification mark, a financing contract, or the right to supply a public project. Those are the places where an industry can either deepen local capability or quietly reproduce the dependency it was supposed to reduce. And this brings us to the final promise still waiting in the background. We now understand what the chain would require. We understand where control could concentrate, but we still do not know whether the economics work. Two missing numbers will decide that far more clearly than any photograph of a bamboo building. Before we reveal them, we need to ask a more practical question. What would Burkina Faso actually have to build, measure, and correct for the transparent future to become more likely than the captured one? The question now is not whether Burkina Faso should believe in bamboo. The question is, what would have to exist for anyone to trust the result? Start with the resource itself. Before factories, before public contracts, before headlines, Burkina Faso would need a credible inventory. Which bamboo species are available where they grow, how many hectares can be harvested sustainably, and how much usable material can be supplied every year. Because if the supply is irregular, everything downstream becomes unstable. A treatment center cannot plan shifts. A processor cannot promise delivery dates. A contractor cannot price a project, and a farmer cannot know whether planting more bamboo will create income or simply create surplus with nowhere to go. So the first mechanism is measurement. Not how many seedlings were planted, but how much construction-grade bamboo can actually reach processors every year. Then comes treatment and drying. If durability is the bottleneck, Burkina Faso would need facilities capable of treating material consistently, controlling moisture, rejecting defective stock, and documenting the process. The important metric is not how many treatment centers exist. It is how much usable material leaves them, how much gets rejected, and how long certified products are expected to last. If that system fails, a cheap material can become expensive through repairs, replacement, and loss of trust. Third comes testing and standards. Universities, engineering bodies, laboratories, and standards agencies would need to define what bamboo can safely do in specific applications. Compression, tension, bending, fire, termites, joints, durability. Not every bamboo product needs to pass every imaginable test, but every approved use needs a clear performance requirement. Otherwise, one failure can damage confidence in the entire category. The fourth mechanism is skills. A bamboo industry does not only need growers. It needs treatment operators, carpenters, machinists, engineers, inspectors, maintenance technicians, and eventually people capable of improving the machinery itself. This is where imported technology can either become a bridge or a trap. If local workers learn to operate, repair, adapt, and eventually manufacture, more of the equipment dependence falls. If every breakdown requires foreign technicians and imported parts, the system remains fragile. Fifth comes procurement. Burkina Faso would not need to replace steel everywhere to test the idea. It could begin where bamboo is technically appropriate and compare pilot projects against conventional alternatives. What did the component cost? How long did installation take? What maintenance was required? Did it meet safety expectations? Could local firms supply it again without outside emergency support? A pilot that publishes those answers is more valuable than 100 promotional photographs. And the sixth mechanism may be the most important: a public scoreboard. Not a scoreboard of speeches, a scoreboard of performance. How much usable bamboo entered actual buildings? How much was processed locally? What share of the finished product depended on imported inputs? What did it cost after treatment, transport, testing, and installation? How many technicians were trained? How many projects were still performing after 1 year, 3 years, and 5 years? Those numbers would make it harder for both supporters and critics to hide behind slogans. And that is the point. Self-reliance is not proven by planting bamboo. It is proven when a system can repeatedly turn a local resource into a safe product at a competitive cost while keeping more capability inside the country. Those measurements may sound technical, but for ordinary people, they decide something much simpler: whether a farmer plants again, whether a worker gets another week of shifts, and whether a family can actually afford the home built from the material everyone once called green steel. Now strip away the policy language and follow the bamboo into ordinary life. Start with the farmer. In the best case, bamboo gives him something rare: a crop, tied to a buyer who needs predictable volume year after year. A reliable buyer can justify irrigation, better planting material, and another season of investment. But the same crop can become a trap if the processor never arrives. Bamboo takes time to establish. Land tied up in a new crop cannot instantly be switched back when demand disappoints. If farmers plant because the idea is fashionable, but processing capacity and buyers do not grow at the same pace, the result is not sovereignty. It is stranded supply. So the farmer's real question is simple: will someone buy what I grow at a price that lets me plant again? Now follow the chain to the worker. A bamboo industry could create jobs, but jobs created is one of the easiest numbers to celebrate and one of the hardest to understand. There is a difference between a worker cutting raw bamboo for low wages and a technician operating a treatment system, a machinist producing engineered components, a carpenter building standardized assemblies, or an engineer testing structural performance. That latter matters. Cutter, treatment operator, machinist, carpenter, technician, engineer. The deeper workers move into that ladder, the more capability stays inside the country. And imported equipment matters here too. If machines arrive but local workers only learn which button to press, the country gains production without gaining much technical independence. If workers learn maintenance, diagnostics, calibration, and eventually adaptation of the machines themselves, the same import can become a bridge toward domestic capability. For the worker's self-reliance is whether today's job teaches a skill worth more tomorrow. Now follow the product to the family building a home. This may be the hardest test of all. A family does not experience industrial policy as a percentage of import substitution. They experience it as a price. Can they afford the material? Can a local contractor install it properly? Will it survive termites, heat, moisture, and years of use? If something fails, can it be repaired without waiting for a specialist or component from another country? And will the home still be affordable after treatment, transport, certification, labor, and maintenance are added to the original price of the bamboo? American viewers may recognize the pattern. When lumber or steel prices rise in the United States, the effect does not stay inside a commodity market. It moves into contractor bids, renovation costs, housing prices, and eventually the budget of an ordinary family. Burkina Faso faces the same basic supply chain logic, even if the materials and incomes are different. That is why local is not enough. A material can be grown locally and still produce an expensive house. A factory can be domestically owned and still depend on imported parts. A project can create jobs and still fail to build advanced skills. And a country can reduce one category of imports while creating another dependency deeper in the chain. This is why the final two measurements matter more than every photograph of a bamboo house. One tells us whether Burkina Faso can supply enough construction-grade material consistently year after year. The other tells us whether ordinary people can afford to use it after the entire industrial chain has taken its share. At the beginning, this looked like a story about bamboo versus steel. Now the real test is clearer. Can Burkina Faso turn a local biological resource into income for the farmer, capability for the worker, and a safe, competitive product for the family? If those three outcomes move together, the idea begins to look like an industry. If they do not, the bamboo may still grow, but the system will not. So where does that leave the bamboo question? Start with what is real. Burkina Faso does face substantial import exposure in iron, steel, and related products. Bamboo is already recognized among natural materials used in the country, and the material has genuine engineering potential in selected construction applications when it is properly treated, designed, tested, and maintained. What is not yet proven is just as important. We do not have verified evidence of a national bamboo-to-construction industrial system operating at scale under Ibrahim Traoré. We do not have a verified national substitution percentage. We do not know the annual volume of construction-grade bamboo that Burkina Faso could supply sustainably. We do not have a public certified delivered cost showing whether bamboo components can compete with the materials they would replace. And that brings us to the two numbers promised at the beginning. Number one, annual construction-grade bamboo supply. Not how many seedlings are planted, not how many hectares look green. How much usable, treated, graded material can reliably reach builders every year? Number two, certified delivered cost. After harvesting, treatment, drying, grading, processing, transport, testing, installation, and maintenance, what does one usable bamboo component actually cost compared with the conventional alternative? Those two numbers change the verdict. If supply is too small or unreliable, there is no industrial scale. If delivered cost is too high, there is no meaningful substitution. But if both numbers become competitive in selected applications, then bamboo stops being only a symbol. It becomes the beginning of a value chain. And notice what those numbers prevent us from doing. They prevent us from confusing plantations with production capacity, with output, or a striking demonstration building with an industry. They force the story back toward performance. That is what should be measured next: usable, annual supply treatment throughput, certified applications, imported input share, local value retained, real project performance, and the number of buildings still working safely after 1 year, 3 years, and 5 years. That is also where the politics becomes more serious. Self-reliance is not proven when a local material appears in a photograph. It is proven when farmers can sell into a reliable market, workers move into higher value skills, engineers can certify performance, firms can maintain the equipment, and families can buy the final product without paying for hidden inefficiencies. So here is the question worth debating. If bamboo proves safe and competitive in specific applications, should Burkina Faso use public construction projects to create the first guaranteed market for a domestic bamboo industry, Or should that risk be left entirely to private builders? Share your answer below and subscribe if you want us to return when new performance data makes this test measurable. Because a stalk can grow in a field, sovereignty has to pass the load test.